Hello, class, and welcome to Algebra 1, Chapter 7.3, Solving Inequalities with Multiplication and Division. Today, there's only one rule that you need to understand and master, and that is this rule. If I have an inequality, like, let's say, 3 times x is greater than, I don't know, let's go with 25. Let's go with 15. When I divide or I multiply by a positive number, I need to divide on one side and divide on the other. 3 divided by 3 will give me 1. 1 times x is x. 15 divided by 3 is 5. This remains as x. The inequality, as you notice, stays the same way. It doesn't move. The answer here is any number that is bigger than, greater than 5. Okay? That's the solution to this kind of problem. So again, if you are multiplying or you are dividing in an inequality statement, the sign stays the same. The sign stays the same. If you are multiplying or dividing with a negative number, the sign switches. So watch, the exact same problem, but this time the 3 is negative. Here's what goes on. You divide by -3 to isolate the variable, just like we did on the other side. -3 divided by -3 is +1 times x. 15 divided by 3 is -5. But now, notice, the very second that I divide by a negative number, I must switch my sign because the solution means something different. And I'll show you. This answer is x is less than -5. So now let's break these apart to see what it means. The way we can view this is on a number line. For the first one, here's what happened. We have 0. The answer for this solution, for this problem of what times 3 gives you something greater than 15 is any number for x that is bigger than 5. So watch this. Here are the numbers bigger than 5. Or here are some of the numbers bigger than 5. 5, 6, 7, 8, 9. Let me just pick any of those numbers, okay? I'm going to pick 6. If I select 6 for x, which is a number larger than 5, I would get 3 times 6 greater than 15. Or said another way, if x is 6 and I multiply it by 3, will I get a number that is larger than 15? And the answer is 3 times 6 is in fact 18. And 18 is in fact greater than 15. So you can see how this works, that the answer or the solution is any number that is bigger than 5. You put any number bigger than 5 inside of x for this, and you will get a number that's bigger than 15. Now, on the other hand, for the negative side, using the same approach, I have my number line. The reason I switch my inequality sign is because what I'm saying has changed. The negative changes the nature of the answer. So here's what we mean. The answer says x must be less than -5. So here are the numbers less than -5. Here's -5. -6, -7, -8. Let me select a number less than -5. Again, -6. If I put a -6 into my original equation, not the one that switched the sign, but the one with the original sign going this way, will my answer be true? Let's see. -3 times -6. Is that answer greater than 15? And I think some of you can already understand and guess that it is. -3 times -6 is positive, because a negative times a negative is a positive, is positive 18. Is positive 18 greater than 15? That is true, right? But that only works if you pick a number that is less than -5. So it's -5 and every number to the left. If I picked a number that was greater than -5, let's say I picked 0, right? I would get -3 times 0. Is that greater than 15? Well, -3 times 0 returns me immediately to 0, and 0 is not greater than 15. So that's what happens. Negatives change the nature of how your answers are going to come out. Because a negative times a negative is a positive, the sign switches. So at the end of the day, what am I telling you? This is what you take away. In an inequality, if you divide by a positive, the sign stays. If you divide, or I mean also multiply, right? If you multiply or divide by a positive, the sign stays. If you multiply or divide by a negative, the sign switches. All right? You multiply or divide by a positive, the sign stays. If you multiply or divide by a negative, the sign switches. Let's do a couple more just to practice. All right, let's go for, here's how your book will do a division problem. It will say x divided by 4 is greater than 3. I like to rewrite these, okay? There's two ways you can solve this problem. You can rewrite it x divided by 4 is greater than 3, or you can leave it as a fraction. I prefer to do it in the second form, but I'll do both for whoever likes to do what. So now I need to get the x by itself. I need to isolate the variable. To do that, I need to do the opposite or the inverse operation of what's going on. What's going on here is a division, x divided by 4. So if I'm doing this first one, I'm going to multiply by the reciprocal, which is 4 over 1. You flip the fraction. What I do to one side, I must do the other. So 3 times 4 over 1 over, and I have to change the 3 into something I can operate with, so I change it into a fraction. So over here, we'll get cross division will give me 4 divided by 4 is 1. 4 divided by 4 is 1. Here I'd get x times 1 over 1, x over 1 is greater than 3 times 4 is 12 over 1. If I clean this up, I go straight across. X times 1 is x. 1 over 1 is 1, or 1 times 1 is 1. X is greater than 12 over 1. Any number divided by 1 is an x, or is itself. So in this case, x divided by 1 is 1, is less than 12 divided by 1 is 12. That's if you're going to use fractions. If you feel comfortable using fractions, go ahead. If you don't feel comfortable using fractions, rewrite the problem like so, where you have the numerator divided by the denominator, and simply do this. I need the inverse operation of divided by 4. It's multiplied by 4. What I do to one side, I do to the other. This leaves me with x. This cancels each other out. They're inverse. Divided by 3 times 4 is 12. Some of you might be looking at this and saying, well, that was so much faster. It is. I just need you to know how to do both ways, all right? It's up to you how you want to solve it, but I show you both ways. Now, I prove it. All I need to do is pick a number that is less than 12. So any number less than 12, 0 is less than 12. That's my favorite number to choose. I'm going to plug this 0 into the x spot for my original equation. So if I replace x with 0, 0 over 4 is greater than or is less than 3. Any number, 0 divided by any number will leave you with 0. 0, is it greater or less than 3? It is. Therefore, my answer truly is any number standing in for x that is less than 12. How do I show that on a number line? You know how to do this. Draw your number line, have a 0 here, have your positive 12 on this side. It's not equal to, all we're doing is starting there. It's 12 and any number less than 12, or a number that 12 is greater than. So any number lower than 12 will work here. That's how you do that problem. Let's try another one. I'm going to see if you can race me here. We're going to do a multiplication problem. Let's try this one. I've got a negative. Ooh, there's the secret negative. Negative 6 times y is less than negative 18. So what's asking us is, what numbers can you put in this y that if you multiply them by negative 6, they would be greater than negative 18? How do I do this? Well, see if you can race me. I do the inverse operation of multiplication. This is negative 6 times y. I need to divide by a negative 6. Negative 6 divided by negative 6 is 1. So I'd end up with 1y and negative 18. What I did to one side, I must do to the other. So negative 18 divided by negative 6. And as you notice, as soon as I switch my negative over here, as soon as I divide by a negative number, I need to flip the sign. So the sign is flipped. Negative 18 divided by negative 6 is going to be a positive 3. So 1 times y, 1 times anything is just itself. So y must be less than 3. So any number I choose, if it's less than 3, if I plug it back into this original equation, it should be greater than negative 18. So let's pick a number on the number line that is less than 3. What are some numbers less than 3? Well, 0. 0 is less than 3. Let's pick that number. So if y is 0, what happens? I rewrite my original equation. Notice the sign is now in the same place it was when we started. I replace my y with 0, the number I selected. Negative 6 times y, which is now 0. Negative 6 times 0, 0. Greater than negative 18. Is 0 greater than negative 18? I almost said no for a second. I was about to freak out, but it is, right? No dollars are definitely greater than owing somebody $18, right? You have more money in your bank at $0 than you do if you owed the bank $18. So our answer is y must be less than 3. And remember, if you divide or multiply by a negative, you must switch the sign. Okay, let's do one more with here we go. We got a 3b. is greater than or equal to 21. All right, let's give you 15 seconds to see if you can solve this. What could be equal? Or what could be B? Which numbers could be B? 15 seconds. All right, that's time. Let's see what you did. Well, first I realized there are no negatives, so my sign is going to stay the same throughout. Now to isolate the variable b, all I need to do is a simple division of 3 to remove the multiplication. When I do to one side, I do to the other. 3 divided by 3 is 1, so I've got a 1 times b. Again, you don't really need to write the 1, but some people need to see every single step, so here we are. 21 divided by 3 is 7. The sign does not change. 1 times b is just b. B must be greater than or equal to 7. Let's pick a number that's bigger than 7. I'm going to use 10 because that's an easy number. If b is 10, does the original equation work? The original equation was 3 times b will be greater than or equal to 21. I chose 10 for b, so 3 times 10. Will that give me a number that is greater than or equal to 21? 3 times 10 is 30. Is 30 greater than or equal to 21? 30 is definitely greater than 21, so therefore it works. My answer is B must be greater than or equal to 7. All right, ladies and gentlemen, I hope that you understand that this is quite simple. Number 1, you learned today that if you divide or multiply in an inequality by a negative number, you need to flip the sign, flip the script. If you are multiplying or dividing by a positive number in an inequality, you leave it alone. And always make sure you test your answer. All right, if there are no questions, which there can't be because this is a pre-recorded conversation, we will see you in the next video.